Hi, welcome to the new video. So the questions which are about the series and a parallel combination of springs are another challenging and confusing questions for the IB students. Well, in this question, I will not just find out the answer, but I will tell you conceptually that what if we hang an object with a spring? Will the two springs will have a equal extension after the attachment of the block or not, and how the force is distributed. Okay, so let's dive in the question. So as you see that these are the two springs, and remember, first of all, these two springs are have the same spring constant, so the value of k, right? And you know the spring constant k is basically tells you the stiffness of the spring, right? That how hard is the spring. If this k value is large, it means it is hard to produce the extension in a spring. It is difficult to elongate the spring. Okay, just like the springs of the automobiles, right? But the springs, the very slinky and the soft springs, always have a less value of the spring constant. Okay, so if we attach a mass, a block with it, what will happen? Obviously, the weight force will exert on this block. Now the weight force will exert on this block will be downward, towards the center of the earth. That is equals to mg. So for example, in this question, the mass is 2 kilograms. So if I take the value of mass 2 times, if I take a value of g10, so it is 20 newton, right? Now students, here's the is a challenging part, that what, and I will get the answer by two methods, so please watch the full video. Now, this how this 20 Newton is transferred on the upper side. Now, in order to understand it, okay, what if I just attach a string with this block? Okay, then what would you say? Okay, so the weight force will be same, 20 Newton. But here's the catch. You would say to me that the force of tension should be equal to 20 Newton at this point. And since the on the other end of the string, which is attached to the rigid, the roof or the support, it should be 20 Newton. So that's why the support is also applying 20 Newton upward to avoid the block falling, or to avoid the string to break. So now, dear students, don't you think that this string has acted as a bridge or a conduit? This has acted as a the transmission of the force, right, between block and support. So just resemble the string concept to this spring. Okay, so how the spring is acting as a bridge, I tell you. So at this point, dear students, that force must be 20 Newton. Okay, that is upward. Now, dear students, this is a point of contact, the point where the two springs are attached, the identical springs are attached. Now, if this is 20 Newton at this point, so it would be 20 Newton at this point downward. And these two 20 Newtons are pair of forces. Okay. Now, at that point, in order to keep the connection stable, the 20 Newton must be applied upward at that point. And then at that point, the other point of the spring, so this should be 20 Newton downward. Okay, now you see that I have still made a deficiency of one force, and that is the force applied by the support that is upward, and this is 20 Newton. Okay, I hope you are not getting confused with a lot of forces. Okay, I explained you. These two forces are internal forces. They are balancing each other. Okay, just like this 20 Newton and 20 Newton are balancing each other. And this 20 Newton and 20 Newton are balancing each other. So at the end, what you see is that the one force that is upward applied on a system and the one force that is applied downward on a system. Okay, so don't you think the spring is acting as a bridge? Okay, so what will happen now? Due to the weight of this block, both springs will undergo some elongation. And my point is that this spring, as you see in the diagram, that both springs are experiencing same force. Okay, so the same force is transmitted. Okay, and what is that force? That is 20 Newton. Okay, so what will happen? As I told you, the same force 20 Newton has elongated the both springs. I mean, like, don't you think the spring will elongate a little bit? Right? So you see that this is a point of contact. Don't you think it has moved down, right? So you can say it is the delta y1. Okay. All right. In the same manner, the other spring will also elongate the same length because the same force is applied on both of them. Okay. So, and forgive me about a little bit trying mistakes. So you see that finally, and this is the delta y1. So now you will simply apply the Hooke's law in the method number one, right? So Hooke's law is says that the spring force is equals to the spring constant times delta x, since the we see the extension in a y direction. So let's say delta y. Okay. So the delta y would be equals to the spring force over k. And I'm just calculating here magnitude. That's why I have not written here the negative sign. I think you will be thinking about it. So what should be the value? Okay, the spring force is equals to the weight. As I told you, 20 Newton is applied on both springs. Okay, so and this 20 Newton will not be applied if these two springs will be in series. Okay, I will make another video on it. So the K is a constant which is 100. I'm sorry, this is 200, right? So 200, and that is 0.1 meter. So it means that 0.1 meter up, it has moved down. And as well as, don't you think that the spring force is equals to, so delta y2 is equals to the spring force over k. Okay, so we will get the same answer, in fact 20 over 200. So it is also elongated by 0.1 meter. So lower and upper are both by the same value. That's why it should be A. Now please don't skip the method number 2 because that is easier than this one, but I preferred this one because I had to talk with you about the concept that how the force is transmitted in the spring. Now in a second method, why not, if you treat the whole the system of these two springs as one spring, and if I replace it, that one spring, and whose spring constant is k equivalent. Okay, now we can find out the k equivalent value, and this is the weight, that is 20 Newton downward. And what is a k equivalent? Now when the two springs are in series, we always apply this equation: 1 over k equivalent is equals to 1 over k1 plus 1 over k2, right? But I always prefer a very easy technique. You just multiply the 100 and 100, sorry, 200 and 200 in numerator, and add them in denominator. Okay, that would give you the same answer. Okay, so their answer will be equals to 100 Newton per meter. So yes, students, so finally, what is the delta y value? That is a total extension in both strings, that you can say it is a sum of the two extensions, right? It will be equals to this force, the spring force, which is obviously, dear students, 200, sorry, 20 Newton, and the downward force is 100. Sorry, the k value is 100. And finally you see that the total answer is your 0.20 meter. And as I told you that this is a sum of delta y1 plus delta y2. So that's why, since the two springs are identical, that's why they both will have 0.1 meter and 0.1 meter. As you see, that is pretty easy compared to that one. But you must know this equation in order to solve by this method.